It's all relative. So I want to remind you guys real quick, there is a quiz tomorrow and Thursday in the labs, 7-1 through 7-4. We're almost done with material, which is crazy. We've got one section in 8 and 2 sections in 10, and then that's all the material for the semester. It's crazy. It's getting towards the end. So I just want to say real quick that I know this time of year, especially if you're taking several of the classes, can get pretty insane. So the best thing in the world to do is just to be open with me about, if you're getting behind on homework or whatever, you just got to talk to me. And I can try to help you figure out how to get caught up. I can help you figure out how to prioritize things, whatever. Just a reminder, too, if you are having a lot of trouble with factoring still, you have got to come see me or get some help, because as you're doing Chapter 7, I'm sure you're realizing, like what I said, factoring is everywhere in there. In fact, once you learn it, it's everywhere, because we had to hide those problems from you before you learned factoring. And now we're like, look at all these problems that exist. Holy shit. Okay. So, with that said, last time we did this crazy stuff, the intersection. We talked about bouncers at bars and stuff. Right, the or and the and. Like it. So the or is what symbol do we use for the or? Yeah, U. And the nice thing is it's called the union. Oh, this is page 196. I'm just using it to write notes right now. Alright, so or, the symbol is a U. And the nice thing is the name of the or, the official name, is the union of two sets. And the symbol is upside down U, which is also kind of like an A missing the middle bar, which is nice for and. And the name for this, unfortunately, is intersection. But even that makes sense. It's the intersection of two sets. So for the answer, for something to be in the answer of an and, it's got to be something that's in both of the sets. Stay with me. All right. Now I'm hoping this idea is relatively simple compared to some of the other stuff we've done this semester. I mean, some of you guys should be like, oh, thank God for this shit. But, for some of these problems are especially simple. So, for example, this one up here. I don't think we did this one. Well, we sort of did this one. We did this one. I kind of added it on somewhere. The union of these two. Remember this? We did this one the other day. The union of these two would just be all the numbers. You just don't write 1, 2, 3 twice. Right? You wouldn't say, okay, Bob, come in. Okay, Bob, come in. It's like, I'm in. What the hell? Is everybody with me? What would the intersection of these two be? 1, 2, 3, because those are the only elements that are in this one and this one. I like it. So very often in English, the word and actually means two different things. We don't realize that very often. And, in one sense, means you're adding more people. You, and you, and you. That's the wrong way to look at it. In this sense, it's like the scholarship thing. You got to do this and this, less people, and this, less people, and this. Now not Jeff. Shit. Turn the page. Okay. All right. Now, real quick, we didn't do a problem like this, but just to remind you guys, I'm pretty sure we did a problem like this earlier this semester, but I kind of skipped this because it is sort of old news, but thoughts, but maybe not. The really funny thing about this problem is, how do you solve equations? Whatever you do to one side, you do to the other side. So how do you solve, how many sides does this thing have? 3. It's got a left side, a right side, and an inside, right? So how do you get m by itself? What's the first thing you would do to try to start to get m by itself? Subtract 3. And where would you do it? All 3 sides. Not both sides, but all sides. So you subtract 3, subtract 3, subtract 3. Shit. So then here you get 7, so the 2m, less than or equal to 12. And so the last thing you do is divide by 2. So you get negative 7 halves, less than or equal to m, less than or equal to 6. Rawr. Now how would I graph that? That was neat. I'll answer your question in a series of beats. Alright, I love you guys. Who gives a shit it's a fraction? Watch. I put negative 7 halves there. Ooh, that was hard. Put 6 over there. I'm going to trust in the fact that you know how to count. I'm going to trust in the fact that you know where negative 7 halves would be if I made you put all the tick marks. So screw all the tick marks. What I'm more interested in is what symbols do you put on those?
Right.
And where do you shade? Uh-oh. Now what is this? This is a hidden word here. This is hidden. This is a hidden and. M has to be less than or equal to 6, and it's got to be greater than or equal to negative 7 halves. So the quick way to say this shit is m is between negative 7 halves and 6. So let's try this again. Where am I going to shade? In the middle. So that's where the answers are. And then like you said earlier, what symbol do I put on those? Bracket, because it's allowed to equal. Poor little 7 got lost. So how do I write that in interval notation?
Negative 7.
Yeah, negative 7 halves up to,
Negative 6.
sorry, that's not a negative symbol, bracket.
Oh, yeah, just
6. And then you put the same symbols on it. That's, come on. So when it's got 3 sides, it's beautiful. The graph is exactly the same as the interval notation. So the thing to realize is, see how that's a sandwich? Remember that weird, weird Waller and his freaking sandwich? But and is a sandwich. Or is the restraining order. Stay away from me, right? And is stay close to me, or is get away from me. Maybe. Okay. Alright. Moving on. I'm going to turn to a page and I'm going to tell you what it is because it doesn't matter. I just need some blank space. I keep forgetting my poor little whiteboard thing. Alright. Do me a favor, guys. Graph that for me. Graph that. And the number line.
4.
So what number am I going to put here probably? 4. Yes, because 4 is the divider, right? Just to look at this really strange way. 4 divides between answers and not answers. Right? What does it mean when you shade something? That means that is where the answers are. So what's it mean when you don't shade something? That's where the not answers are, or the answers aren't. Either way you want to say it. You guys semi with me here? So how do I break a line in half at a point? So doesn't this break it, and don't quibble with me about you can't cut infinity in half. Screw that shit. All right. Or some of you guys I wasn't even going to say that. Yeah, all right. And then, of course, on the 4, you're going to put bracket. Now, which way do I shade? Yeah, because let me check. If I play a 5 in there, is it true? Is 5 bigger than or equal to 4? Yes. If I put a 3 in there, is that true?
No.
No. So I'm going to shade in the direction where the thing worked. So if something works, that means everything on that side works. If something doesn't work, that means nothing on that side works. So that 4 divides answers from non-answers. I am way over analyzing this for a reason, because when I step it up to be 2 variables, now we're going to want to start to talk like I just did. It's the same exact idea, it's just that you got to bring the whole idea in. Deep breath. So what if I had this? What if I had x plus y greater than or equal to 4? Now I've got 2 variables. I can't just use a single number line. I have to use both. I have to use a full coordinate plane. Oh, shit. Aw. What cuts a plane in half? What kind of thing? Does a point cut a plane in half? If I have a piece of paper, how do I chop it in half? Chop! Right? With a line, right? A line would cut that thing in half. Or cut it this way, I can cut it that way. A line is going to cut it. Are you guys understanding? If I have just a line, a point would cut it in half. But if I got a freaking plane, a line cuts it in half. Yeah, like it? Stay with me now. It's the same idea as before. Just like the 4 broke it into answers and non-answers, now a line is going to break it into answers and non-answers. So what line am I talking about? We'll solve this sucker for y. So I just have to subtract x, so I get y greater than negative x plus 4. How do I plot that line? What's the slope? Negative 1. And what's the y-intercept? 0, 4. Look at that. I've taught you well. I didn't hear any 4s. I have 0, 4. I like it. Alright, whatever, man. We just say what makes you happy. So you get off of that. Alright, so what do I plot?
0 for y-intercept.
Yeah. Wow, John. Yeah. So 0, 4. And then from there I go
Down 1.
down 1 over 1. Down 1 over 1. Down 1 over 1. Okay, that's fine. So that would be the answer if this was x plus y equals 4. That would be the answer. But not only does this include all the points where the x plus y equals 4, that's all the points on the line, but also where they're greater than 4. Aw, shit. So how do I do that? The same way I did this, by overthinking it a bit. I pick a point, and I plug it in, and I see if it works. Now watch, guys, watch. I always pick 0, 0 if I can, unless 0, 0 is not on one side or the other. If the line goes through 0, 0, I can't choose it. That's not going to be on one side or the other. If I plug 0, 0 in and it works, that means all the answers are on this side. If I plug 0, 0 in and it doesn't work, that means all the answers are on the other side. That's the equation. Yeah. So if I plug 0, 0, this is what's called my test point. Is 0 plus 0 greater than or equal to 4? Is that true? Is 0 greater than or equal to 4? No. So this entire side must be the not answers. The other side are the answers. So every point on this side would work. No point on this side would work. Alright, so read this. Sometimes some of the incredulity is that it's that easy. Sometimes it's what the shit just happens. I don't know where we are. So watch this. What's the point that's in here? Isn't the point 5, 3? That's in there, right?
Yes.
What's 5 plus 3? And that is bigger than 4. Hey. What's the point that's on this side? Like negative 1, 1. Right? Isn't negative 1, 1 on that side?
Yes.
What's negative 1 plus 1?
0.
0. That is not, you see, it is not an answer. So the line, now let me show you a slightly different one. So that's the official textbook method. It's called the test point method. You graph the line, that's the divider. Just like you did when you put the 4 on the number line. You first put the divider point on, and then you shade one side or the other. It's the same damn thing. So now I've got a freaking plane, I've got to draw a line to cut that sucker, and now it's one side or the other. Because the inequality is all about going one way or going the other way. Maybe. So a slightly different way to look at this. The way that I do this, it's not always the way that students want to do it, but the way that I do this is, what's this say? All the y's have to be bigger than or equal to this line. So where are all the y's bigger than this y? Up. So I'm going to shade up. It's greater than. I'm going to shade up. Kabam. I just don't like the test point myself, but the reason that method is harder is because the steeper the line gets, the harder it is to tell what up and down is. This is not that bad. This is obviously up and this is obviously down, but if that's really steep, it looks like left and right, not up and down. Okay, maybe you guys understand. So you can always do the test point if you want to. Okay, let's try another one. Let's try one out of the book here. Here we go. Wow, that's too much like the orange. Yeah, let's try this one. This is page 198. 198. Cooperative with the book. All right, first thing I want you to do is solve this for y. So you should get this. Right, subtract 3x, divide by 4. Now, be really careful. Notice something that's different from the one we just did. The inequality in the one we just did was or equal to. So remember back in the day when you did open circle, closed circle? So we're going to do something very similar. So when I draw the line, I'm not going to do a solid line. That's like a closed circle. I'm going to do a dashed line, that's like an open circle. Since it says less than, it can't include the points on the line because that's where they are equal to. So I have to do a dashed line to say these don't work. It's like an open circle. Same idea.
So all equations that don't have an or equal to will be
Dash lines, I like it. So go ahead and plot that line, but remember, connect it with a dashed line. You got the y-intercept, you got the slope. You can do this.
When you do the zero test, does it matter which one's better? Top or bottom?
It doesn't really. I pretty much always go to the beginning because it's sort of quicker. Yeah, but it doesn't matter. All right, what's the y-intercept?
0,
And what's the slope? I go down 3 over 4. Going to connect that. Let's see if I can do this. Sure, John. That's close enough. For me, that's what it is. Now, I'm going to shade this side or that side. So for those of you who like the second way, I'm going to shade, yeah, I'm done. Now, if you use a test point, 0, 0, when you plug, it doesn't matter, there's a question, doesn't matter which one I plug it into, no, because these are the same. So if I always use the first thing though. 0 plus 0, is that less than 12? Yes. So that means that works. So all of these on this side work. None of the points on that side work. Okay. Yeah. Here, try one more here. Let me see what I find. Here, page 215. Do number 8 real quick. This one should be relatively easy. It's already solved for y. Y-intercept is
0, 5.
5. From there I go.
Down 1 over
1 over 1. What kind of line is it going to be? Dash, dotted? Whatever you want to say. This is y greater than, so I would shade out. Or if you put 0, 0 in, is 0 bigger than 5? No. So you don't shade where 0, 0 is, because it didn't work. Shade the other side. Please let that make so much sense it's scary. Please. Yes, sir?
Why did you plot 3 points instead of 2?
I don't know. I just did. Doesn't matter. I just did the slope one more time, and yeah. Just because I need help to make sure I do it straight. Yeah. Yes.
Can we do some that have like the or and? There's some other keywords maybe at the top.
Oh yeah, no. Those are. We can do that for review. That's the stuff you've already done. But it's not like a graphic thing. They just want the sets. Yeah. Let's focus on what we're doing right now first. So here, back on page 198. I wanted to skip this for a minute. Number 3.
She didn't forget.
Oh, man. Yeah, that's the list of things I can't use.
I remembered it.
I don't know, when I teach stats, I do talk about O's and I's, but for different reasons. So the weird thing about this is there's a missing x. So what would y equal negative 4 look like? Alright, so y has to stay the same. What happens if y changes? How do I move if y changes? Up and down. If y has to stay the same, I can't go up and down. I can only go this way. Well, you can. So y equal negative 4 would be a horizontal line here. It's going to have to be dotted. Now this one is simple. I'm not going to use a test point for this. Where are the y's bigger than that? Up. Yeah, that's where the y's are. And then they say y bigger than negative 4. So all that works. However you want to do it. I love it. Alright. So, now, to get us a little bit closer to what I was talking about with these finding the safe zones. I don't know if you guys remember that. So the opposite of danger zone. Let's see, there's a decent one. Ooh, I like that one. Let's do this one. That was gross. So what I want you to do, see how there's two problems here. Do this one on that number line all the way. Get to the point where you shade it. Stay with me now, guys. On top of that, you do this one. The answer is going to be where the shadings overlap. So just, yeah. So that's what you should be getting for the 2 when you solve for y. Don't forget, when you divide by negative, you gotta switch the inequality symbol up. Should both be less than. So how do I graph this first line? Yeah, so I got 0, 3, and then I go down 3, over 2. What kind of line is it going to be?
Down.
And which way am I going to shade?
Down.
Down. If you plug 0, 0, is 0 less than 0 plus 6? Is 0 less than 6?
Yes.
Yes. So then 0, 0 works. Now watch what I do. I just do a few arrows. Because it gets a little bit gross when you have multiple things and you're shading all over the damn place. So just put some arrows. Now how do I graph this one? The y-intercept is negative 2. And then I go up 2, over 5. What kind of line is it going to be? Another dashed one. And this one I'm also going to shade down. If I plug 0, 0 in, is 0 minus 0 bigger than 10? No. So I shade away from 0. So the answer is going to be in here. You can see that. That's where both the shadings match up. In here. So then you just make that really evident. That's the answer because that's where both shadings went. So if this represented something like a restriction on the current in wires and a restriction on the length of the wire, this would be the safe place. So if I had something, if I'm like, we want to be here, I'm like, well, don't do that because then it's going to blow up. Oh, okay. So in certain workplaces, and so where they might have graphs like this that show you safe areas to operate in. Load on an elevator, load on an electrical wire, electrical current, electrical circuit, whatever. Places where things that could happen that would be bad. You guys sort of understand? Because I could have multiple. I could have more than just 2. I could have 1, 2, 3, and then this little area in the middle would be my little safe area. So if I want to be here, well, that's too many people in the elevator, they're all going to plummet to their death. If I'm over here, that's a real quick visual of, I can't go there. That's outside the safe zone. It's in the danger zone. So you guys try number 3. If you're concerned that the y-intercept is missing, it isn't. It would just be plus 0, yeah. So this one goes through the origin.
So the y-intercept is 0.
So
Over here and then
over to, oh yeah.
Alright, the second one is the easy one. Hopefully.
-2.
Yeah, -2. Then I'm going to go up from there. Alright, greater than 2x. So 0 is the y-intercept. And then we go up 2 over 1. What kind of line is it going to be? Solid, finally. Yeah. That's close, Jeff. Make that big. There you go. And then, whatever way you use, you're going to end up shading this way. Now, if you like the test point method, you're going to have to use, you can't use 0, 0. But when I can't use 0, 0, I just use 0, 1, or 1, 0. The next best thing. Right? So if I use 1, 0, we plug 1, 0 in. 0 greater than or equal to 2 times 1 is 0 bigger than 2. No, so that's why I didn't shade this way. I shade that way. Now what's the answer? Yeah, so it's got to be above this line and above this line, so it's going to be in here. It's got to be above this line and above this line, so it's going to be in here. It's where the two overlap. Really, it's just one extra step on top of graphing a line. We all should be able to graph a line. Let's see if they have. Huh?
So whenever there's just, it's 2x and it doesn't give you a y-intercept, it'll always just be 0?
Yep. Because plus b, and if it's not there, it's the only number that doesn't show up when you're adding is 0. You don't write that yet. Let's see. Let me give you a little preview of what's to come. I mean, the next thing we're going to be getting into are these like totally radical expressions. What does that reference? Radical. Square root or cube root. So what I say, if I say rad 4, I mean square root of 4. Well, what is the square root of 4? Why? Yeah. What's the understood number that's right here? Yeah, it's the second root. We just don't write it because it's the most used root. Yes, and I am saying root. So, we're getting to, now let me ask this. This is a very strange sentence here, a very strange question. What are the square roots of 25? There's actually more than one square root of 25. Yes. Now, when I write this symbol, though, when I write this symbol, it's understood that I want the positive root. So this is what's called the principal square root. If I wanted the negative answer, I'd have to put a freaking negative sign on it to say I want the negative root. Okay. And why is that? Because what do I square to get 25? 5 or C. So there's two roots of 22 square roots of 25. Two numbers that it takes 2 of to multiply to be 25. 5 and negative 5. But when I write the symbol square root of 25, that wants the positive one. That's why the square root can only be positive. It's by definition. Yes? Always. So what are the square roots of 100? 10 and negative 10. How would I write that with the root symbol if I want negative 10? Negative square root of 100. That's the negative root of 100. What's wrong with me asking this question? Because what times itself is negative 4? Imaginary numbers. No real numbers do that. It don't work. I like it. Now, if you take me for 110 next semester, I'd like to explain, let me just explain this right now, because a lot of you guys know the word imaginary. Have you guys all heard imaginary number before? And this is where part of your brain goes, I knew this shit was all made up. But I think I said this before. When they first came up with the idea of negative numbers, some people were up in arms. They're like, those don't exist. What the shit are you talking about? Negative numbers, I can't have negative apples. So people were all like, those are imaginary. But eventually we got over it. And nowadays, of course, the banks love that negatives exist so they can describe to us what our bank account is. You guys kind of with me? A little bit? Square root of negative number got the same kind of reaction, but unfortunately it just never kind of went away. The word imaginary stuck. People didn't like it. They said, that's bullshit. What's that mean? It's imaginary, so it kind of stuck, unfortunately. We weren't able to change it quick enough. It just kind of stuck. So students got to give up on it and go, well, that's a bunch of shit. What I like to show is the actual physical meaning of it. It's really kind of neat. I'm not going to do that for you now. It's a little teaser. If you don't take my class, too bad. I guess you can just watch the video. I'm going to post it. Right. But it's like the missing part of math that you don't get to see. Is what is the square root of a negative number and what does it mean? Is it really just some bullshit thing like dividing by 0? No, it actually has physical meaning. All right. I think that's enough for today. Don't forget quizzes tomorrow and the next day in the lab. If you go into the next lab, maybe walk slow, don't go right in there. Give Nemi some time to get out of there.
This is the ones in that lab.
Yeah. It's the way I teach it. I mean, this is the same setup.
There's 3 different ones. That's one time, but it doesn't take time.
Oh yeah, you gotta click on more. Yeah, yeah.